students of civil engineering at subject of matrix analysis of structures. We study at the University of Cuenca in Cuenca, Ecuador. Our team developed this program to solve structures that over time and throughout the course we will improve the structures for a more detailed and real analysis.
I'm 22 years old. I was professor assistant at my university in the field of advanced geomatics. I also participated in the fourth national competition in the city of highly workable mortars and in the international competition ACA Mortar Workability in Philadelphia. Here I got the fourth place with my team. I'm currently the president of the ACI student chapter of my university. One of my greatest aspirations is to be a professional of high level in the area of structural analysis, with the objective of developing tools that allow to adapt and apply new technologies in the structural calculation.
Hello, my name is Diana Vasquez. I am 22 years old. Now I am a professor assistant. I am a member and co-founder of the ACI student chapter in my university. I am also the author of several articles that have been published in the journal of my faculty. Now, I am in the 8th cycle of a major and I want to study a specialization in the area of structures. So, from now we have developed and empowering our skills to achieve it with the creation of this program.
My name is Martin Isaac. I'm 20 years old and I am in the 8th cycle of civil engineering. I am interested in the structural engineering field because it's difficult and that challenged me to improve. Designing this analysis program was rewarding because it involved our imagination and developed some of our skills. I want to finish the university and study a specialization in the area of structural engineering.
Hello, my name is Cristian Picao. I'm 22 years old. I am in the 8th cycle of civil engineering. I study civil engineering because it's what passionates me and I would like to be a great professional. With this project, I could see the potential of a technical career as engineering to resolve problems of an easiest way.
The program consists of a main window, where you have the option to choose the units at any time during the execution. The materials to be used can be modified from the Editor tab in the Edit Materials option. Where you can create or delete different materials that have the structure. There is also the option to perform linear and nonlinear analysis to the structure. If you choose linear analysis, you must add nodes and bars manually. If you make a mistake when placing them, can be removed at any time. The program in this step doesn't allow you to add bars that have the same starting and ending nodes. All the properties of each bar and each node can be modified from the tables or from the respective tabs. When we choose the option nonlinear, we choose the node and the direction of the analysis to be able to perform the calculations. In the program, you can also load previously created files. The program does not restrict you to any interface that are modified. For example, you can assign a load to the node 5, a vertical load of 5 tons first, and delete the distribute first of the var 3. To perform the analysis, select the Calculate tab and the respective analysis, for which the data must be recorded.
To enter a new frame in a more efficient way, the option Create is Templates. Here in Insert option in Templates and Draw. The Templates option allows you to enter structures templates in New or Create files. For example, if we choose Bridge Frame, it's necessary to enter 4 parameters. The coordinates of the starting point that can be located in any point of the plane, including existing nodes. In this case, we choose the coordinates x equals 0 and y equals 400. And the legs 1 and 2, such as 150 and 250, respectively. The height of the frame will be 200. In addition, the area for all materials are 20 square centimeters is and the material named Mat2. If you want to preview the frame, click on the Add Frame button, where we can verify if the data entered are correct. To add the frame, you must choose the option to delete it. Once the necessary changes have been made, the structures should be saved. You can choose various frames, like a Warren frame, where coordinate is 500, the length of 200 centimeters, and the height equal to 200 centimeters. Area of 5 square centimeters and the material 2. When all the templates have been added, we press exit. As you can see, the arrays are created and the structure is ready to be analyzed.
Another form to insert draws to our program is with a menu draw. In this option, we can add nodes with double click. And we can add bars with clicks. The program can make zoom to set the points that agree. We can delete nodes or bars. When the frame is finished, we have to press the OK button and the data is added at our main window. When we choose the linear analysis option using any method of data entry, we can run the linear analysis. For example, the network structure where only the 5 nodes have movement freedom. The applied loads are 45 tons in the x direction and exist loads on the elements 1 and 7. The distributed forces can be placed as a function of the length of the element and the equation is calculated from the initial nodes at the final node. Well, when the structure is ready to be analyzed, the Calculate tab is chosen and the respective option is selected. In this case, Linear Analysis option. So I have to choose the folder for save the files. Within the analysis, all editing options are disabled, so you can see the movements of each node or force in each element. An increase of the graphical scale of the force or displacements can be made if necessary. For example, for the displacement, we choose the next factor, or we can change the value. We can use the slider. Once finished, the calculations can be made a report on a Word file with the report name. The file is saved in the folder where the corresponding scans files were saved. In the report, we can see the data entry and the resume of the results of the linear analysis. We can find the matrix of coordinates and the connectivity, the graphical of the structure analyzed, the processing, and the results. If we choose the nonlinear analysis option, we can load existing files. In this option, we must to choose the node and the direction in which you want to perform the analysis. Then we must select the tab Calculate and the option Nonlinear Analysis. We must save the files. With the animation button, we can see how the structure is deformed in the time. In addition, the color change indicates the fluency of the bars as well as the change of the slope in the graphs.
The import of an Excel file exported from SAP 2000 consists of a use of 4 sections of tables. Connectivity data. It contains the connectivity matrices, coordinates, and nodal constraints of the structure. Joint assignments contains different types of loads on local or global axes. Frame assignments. You have data about subsection templates. Material properties. It has the properties of the material assigned to each section's template of the different elements of the structure. Next, we save the file. In this case, the file name is example1. The Excel file includes different sheets in which the structure information is stored in a special format and depends on the conditions in which the structure is located. Our program analyzes the SAP file and compiles the values to perform the analysis of the structure. Select the option File, press in SAP 2000 Import, and choose the Excel SAP file. We note that the same materials and the same loads have been exported. Enter the Calculate tab and choose the Line Analysis option. Save the file and The axial forces and displacements are plotted. We can see the same displacement and the same force values. The color convention is different, but the values of the forces are the same.
Thank you, and I hope you enjoyed.